and this is, I believe, the 13th session of vectors. And we'll begin today by understanding the definition of the operation defined as, or the operation called cross product of vectors. So just as I had stated that when we are discussing about dot products, the term product should not confuse you, because it has nothing to do with multiplication. It is a totally different type of operation which has to be defined from basic. Its definition is completely different to definition of multiplication, or you can say product of scalar quantities, because this is a vector operation. So this particular operation we are talking about, its particular name is cross product. Okay. Or an alternate name for it is vector products. Whereas what we have previously discussed in the last two lectures is about dot products, and the alternate name for dot product being that it is scalar product. So once again, you have to understand that these are two different operations. They are not the same, or they're not even similar in any way. They're very different operations. It's just that we use the term product for both of them, but you have to identify them as cross product or dot product as two separate operations altogether. So the symbol used for cross product is a cross, and that is why the name is that way. So when we put a cross symbol between two vector quantities, it doesn't mean we are multiplying them. It means that we are operating cross product on them. So this symbol is read as the cross product of vectors A and B. Cross product, or we also call it the vector product of A and B. So that is the symbol. Now let's understand the definition, which is the most important thing here. So how do we define this operation? Uh, right. So the definition of cross product is given by this calculation. Cross product of two vectors equals to magnitude of vector A multiplied by magnitude of vector B multiplied by sine of the angle theta between them, and further, this quantity being a scalar, it is now multiplied with a particular unit vector called n cap. So n cap is a unit vector which has a special significance here, and I'll tell you about that. So this is the definition of the cross product, where you can understand that the quantity capital A is nothing but the modulus or magnitude of vector A. Similarly, this is the magnitude of vector B. Theta is the angle between A and B. So immediately you can see how it is different from dot product. There we had cos theta, here we have sin theta. But also how it is different from dot product. There it was AB cos theta, so it was a scalar quantity. But here there is also the unit vector n cap involved. So n cap makes it a vector quantity. N cap is a special vector, it's a special unit vector, in the sense that it is the unit vector which is perpendicular to the plane of vectors A and B. Okay. And it is determined by something called right hand rule, which I'll tell you about. Right hand rule, or sometimes we call it right hand palm rule also. So first of all, note down this definition, then I'll explain to you the significant aspects of the definition. Okay, so now let us understand each of the terms and the significance of each of the quantities in the definition. So the first important aspect to understand over here is that A cross B is defined in such a way that it represents a vector quantity, is a vector quantity. It's not a scalar quantity. Unlike dot product, which used to give us a scalar quantity. Okay. So is a vector quantity such that the magnitude of A cross B is AB sine theta. Okay. And the direction of A cross B is along the unit vector n cap, as we see. Okay. Now each of these quantities has its own significance. So let me explain how that works. So secondly, mod A cross B, which is AB sine theta, the significance of this quantity is that it represents the area of a parallelogram with sides A and B. It is very easy to show geometrically why that is the case, because if you just draw a parallelogram with adjacent sides as A and B, like we used to do in parallelogram law of vector addition or subtraction. So same process, you just draw the two vectors A and B from a common origin, angle theta between them, and then you just complete the parallelogram shape by drawing two supporting lines which are parallel to A and B respectively. So now you can see that in this parallelogram that we are getting here, the base is of length A, but if you drop a perpendicular here, okay, and we'll call it the height h. Now that height h you can see from this triangle's geometry, h upon b within this right angle triangle. If you just notice this right angle triangle, h upon b is perpendicular upon hypotenuse. So that is nothing but sine theta. That means the height of the parallelogram h is b sine theta. Therefore, area of the parallelogram is base multiplied by height. So that is a into h over here. So that becomes ab sine theta. So that is nothing but magnitude of A cross B. Okay. So this is how we understand this statement, that the magnitude of the cross product of two vectors is nothing but the area of the parallelogram formed by using the vectors A and B. Just make a note of this quickly. Now about the direction n cap. Now this is the very important part about cross product. So pay attention. So the direction of unit vector n cap, okay, it is determined by what is called right hand palm rule. Let's see how that works out. So now in that it is very simple that if we are calculating for A cross B operation, okay, draw vectors A and B from a common origin. Okay. So for example, if vectors A and B are like this, suppose this is a vector A and this is a vector B, we'll have to redraw them from the common origin. So we'll place the vector A at an origin and place the vector B also from that origin, from that common origin. Okay. Then place your right hand, okay, in the plane of A and B, which is basically the plane of the paper or the screen on which you're drawing. Okay, but it should be placed such that, now this is very important, placed such that the thumb, that is your right hand's thumb, points along the vector A, and the four fingers point along B. So here we have to place our right hand in this diagram in such a way that our thumb points towards A. So our right hand thumb should be here, and then our fingers should be oriented. The four fingers should be oriented like this, so that they are pointing at B. This is our four fingers. So they are pointing along the direction of B, and this is pointing along the direction of A. Like this. Now, once you have done that, you will see that there are only two ways in which you can place your palm for different types of vectors. One is where your palm will be facing towards you, and the other will be where your palm is facing the other way, it's facing into the paper. So you're looking into the knuckles in your hand. You're not looking at the palm, you're looking at the knuckles. So that tells you what is the direction of n cap. So if your palm faces outwards, that is, it faces you. You're looking into the diagram, so it faces you. Okay. Then n cap is the unit vector coming straight out. Okay. Coming straight out of the screen or the paper, which is a plane of A and B. Which is the case in this diagram. In this diagram, you can see that if you place your right hand like this over here, you see that you're looking into your palm. So in this case, your palm is facing out, it's facing outwards. So that means n cap for A cross B is coming out. Now, on the other hand, if so, this is one possibility, but the second possibility is there that if your palm faces into the plane, okay, then that will mean that n cap is going straight into the plane, not coming out, but going into the plane of A and B. So an example of that would be like this. Suppose when we draw A and B, vector A happens to be this one and vector B happens to be this one. And we want to do the operation of A cross B. So after drawing A and B from the common origin, we'll have to place our hand in such a way, right hand in such a way that our thumb points towards A and our fingers are pointing towards B. So you will see that in this case, your palm will go straight into the plane of the paper like this. So when you place your palm, your right hand palm, so particularly if you're left-handed, you have to be careful not to use your left hand, use your right hand in such a way that you have folded your thumb like this towards A, while your four fingers in this case are pointing like this towards B. So in this case, you will see that when you place your hand like this, you will be looking into your knuckles. Your palm is facing the other way. So in this case, the palm is facing inwards. So because it is facing inwards, you know that n cap will be into the plane. Okay. So just make a note of this method and then we'll practice it with some example diagrams and it will become clear to you how to use this right hand palm rule. Okay. This is very important because this right hand palm rule and the cross product direction from this is used in a number of different applications in physics, especially in magnetism, in rotational mechanics, etc. So in various different chapters in future, we will be seeing the applications of this. So it is very important that you understand how to get the direction correctly by using your right hand palm correctly. Just make a note of this, people. So people, hope you've noted this down and understood this. Now let's just practice out this right hand palm rule with some examples. So this is a situation next where I'll give you some diagrams with different vectors, and you have to just tell the direction of A cross B in each of these in terms of whether it's coming out or going into the plane. Okay, so in this example, in each of the cases shown, okay, express the direction of A cross B as either going into the plane or coming out of the plane. Let us begin. So the first case, so hang on, I'll just give you each of the parts. So in this case, this is A, is the vector B. Now in the second case, this is the vector A, this is the vector B. In the third case, this is the vector A and this is the vector B. And the fourth case, I'm just showing you the geographical directions. Okay. Now A is along northwest, okay, and B is along south, is pointing towards south. So A cross B's direction, if you want. Okay. So just think this through carefully. Understand the concept of palm rule that we discussed in the previous definition, and tell me in each one of these cases, each answer will be either coming in or going out. Each of them will be in terms of the direction of A cross B is either coming out of the plane or going into the plane. Deep, your answers are correct. Okay, Bhavesh, unfortunately, your first answer is not correct. First and third is wrong. Okay, so anybody else who has got the answers or just two people? So here you can see A cross B. If you place your palm like this, now your thumb is pointing like this, and your fingers. You just try to place your palm like this in the screen. You'll see your palm is looking towards you. You place your right hand thumb like this and your fingers like this. You see that it is coming out because your palm is facing you. In this case, you'll have to place your thumb like this and your fingers like this. So you'll see that you'll end up looking at the side where you see the knuckles. The palm is pointing in the opposite direction. So this, in this case, A cross B, because your thumb is pointing like this. So A cross B is going into the plane. Yes. A few more people are sending answers now. Yes. Bhargav, this time Bhargav, you got it correct. Okay. Yeah, all of them are correct. Good. Here also, you'll A cross B. When you work it out same way, you'll see that it is into the plane, going into the plane. Now in this case, you just draw the vectors first. So A is pointing towards northwest. So A is a vector like this, and B is pointing towards south. So B is a vector like this. Now for A cross B, again you have to place your thumb like this and your fingers like this. So you see you're looking into your palm. So here also A cross B is coming out of the plane. Okay, so it should be fairly simple. Okay. And next thing, quick numerical type of example. If magnitude of A cross B is equal to root 3 times A dot B, then find theta, that is the angle between vectors A and B. This one and another example. Okay, so in all of these, just use the standard formula that magnitude of A cross B is given by the relation AB sine theta. So if you just use this over here, you should not have too much difficulty solving this. Just work this out quickly. Yes, Deep, that is correct. Very good. Yes, second case also is correct. Second case, you realize the angle is 120 degrees. Anyway, here A cross B's magnitude is equal to root 3 times A dot B, implies that AB sine theta is root 3 times AB cos theta, or tan theta is root 3. So that means theta is equal to 60 degrees. Okay. And this here means that is equal to 10 now. Mod of P plus Q is 10. And P is 10, Q is 10. So this implies this. Okay. So when you solve this, this will give you cos theta equal to minus half, which means that theta is 120 degrees. So then that means that magnitude of A cross B, sorry, P cross Q, which is PQ sine theta, will become 10 into 10 into sine 120. Okay, so that is 100 into root 3 by 2. So this should be 50 units. Okay, so this is the answer to this part. So just make a note of this quickly. So as you can see, it's very simple. It's just definition based. As you know, as long as you know the formula for mod A cross B and the formula for A dot B, or whatever formula of triangle law wherever required, things like that, you should be able to work out these things quite simply. So hope this is clear, people. Okay, next up we will discuss about some important properties of cross product. So the first important thing we can see is that if theta is equal to 0 or 180 degrees, then A cross B becomes a null vector. So that means if A and B are parallel, that is theta equal to 0, or anti-parallel, theta equal to 180 degrees, then cross product will be 0. And that also will give you the logic of this next thing, that any vector cross product with itself will be 0. The reason is the same, because theta is 0 now. So just make a note of this, people. So this should be pretty clear. Now the next thing, we see the operation A cross B and compare it with the operation B cross A. We will see that there's a minus sign involved because magnitude of A cross B is the same as magnitude of B cross A, which is AB sine theta, which is area of parallelogram. But direction of A cross B is opposite to B cross A. Because suppose if this is coming out of the plane, then this one will be into the plane. For example, we have this and this like this over here. So you can see here that when we do the operation A cross B, it will be coming out of the plane because you place your thumb like this and your fingers towards B. But when we do B cross A, we have to place our thumb towards B and our fingers towards A because the first vector is B, the second one is A. So it will be into the plane. So they are opposite in direction, but same in magnitude. Hence this relationship that A cross B is minus of B cross A. Okay, now next very important property, the last of these properties, if you're doing A cross of B plus C, this becomes equal to A cross B plus A cross C. Yes, Bhargav, it's quite easy to prove actually, but using components and things. Okay. Okay, next up, we look at cross products in component form. So to understand cross products in component form, first and foremost, we have to understand this, that if we take I cap cross j cap, what it will give us. So for that, just visualize your mutually perpendicular x, y, and z axis. So if this is a vector of magnitude 1 along the x axis, this will be I cap. Similarly, this is a vector of magnitude 1 along the y axis, so this will be j cap, and this is k cap. Or if we draw them in a two-dimensional situation like this, if I've drawn I cap and j cap like this, then k cap will be along the z axis, which is coming out of the plane. So they're of magnitude 1 each. So in this case, k cap is the unit vector coming out. So you can see that in this case, it becomes this. Why? Because magnitude of I cap is 1, magnitude of j cap is 1. Theta between them is 90 degrees. So sine theta is 1. Okay. And direction of I cap cross j cap will be coming out. Okay. So from this you can see that magnitude of I cap cross j cap is 1, and the direction is coming out, that you can see from this diagram. So coming out is basically what? N cap is the unit vector along z axis, because coming out in this case, if I take x axis like this and y like this, the direction coming out is the z axis. So that means n cap is nothing but k cap, the unit vector along the z axis. So magnitude of I cross j is 1, and the direction is along k cap. So now you can see this. That means that I cap cross j cap is equal to k cap. Okay, so hope the logic of this is clear to you. Now, similarly, if I cap cross j cap is equal to k cap, then automatically it implies that j cap cross I cap is minus of k cap. This comes from the property that we just saw, that A cross B is minus of B cross A. And also I cap cross I cap will be 0, and j cap cross j cap will be 0. Okay. Because we just saw that any vector's cross product with itself is a null vector. Yeah, this is a standard equation, and I have shown you the logic of it also. Bhargav, I have explained to you the logic of the standard equation also, because the xyz axis are drawn in that way, no? That they are mutually perpendicular, such that if this is x, this is y, then this is z. So I cap cross j cap will give you positive k cap. J cross I will give you minus k cap. Okay, so now based on this, we have the simple formula that suppose vector A is axi cap plus ayj cap, and vector B is bxi cap plus byj cap. Then A cross B will become A expressed in component form like this, cross product with B expressed in component form. Okay. So this you can see will give you the first term ax into bx plus ax into by, okay, plus ay into bx plus ay into by j cross j. Okay. Now from this and this, you can see that these two terms are 0. They are null vectors. Okay. And from this one and this one, you can see that this term is k cap and this term is minus k cap. So ultimately this becomes 0 plus ax by minus ay bx into k cap. Okay. Now further, this can be written very simply as the determinant of this 2 by 2 matrix. So this gives us a simple shortcut formula for A cross B. So this is the formula for A cross B using determinant of the 2 by 2 matrix. So you know that the determinant of this 2 by 2 matrix is nothing but this diagonal minus this diagonal. So it is ax by minus a by bx. Okay, so this is the standard formula. What we've seen before this is basically the logical derivation of it, but from that now we are getting the standard formula, which is very important because when we're doing questions, we will be directly using the standard formula. So hope this is clear. Okay, so people hope this is clear. So for example, we want to calculate A cross B, given A is, let's say, 5 I cap plus 3 j cap, and B is 2 I cap minus j cap, suppose. Okay, so then A cross B will simply become, apply this formula now. Okay, so A's components 5 3, then B's components 2 minus 1 times k cap. So now this thing, so that is 5 into minus 1 minus of this product, that is 3 into 2 into k cap. So this becomes minus 5 minus 6. So it becomes minus 11 k cap. So this becomes A cross B. So note down this example and then try out this one. Oh, that is a simple formula, Harsh. Like, see, if we have four numbers placed into two rows and two columns, then the determinant of this is just given by the formula. You multiply these two, this diagonal term, so A1 into B2, and then you multiply the second diagonal term and subtract it, A2 into B1. You have studied this in maths in 9-10. Kramer's rule for solving linear equations. So for example, if I have 3, 2, let's say 4, 5. So this will become 3 into 5 minus 2 into 4. So this is a very common thing in maths and algebra. You must have seen it at some stage in 9-10. Maybe you're not recalling. You can revise it also once. Yeah, so how much is the answer for this coming to be? Yes, correct. Yes, that's the correct answer. So P cross Q here will become 16 9 minus 3 4. So 48 minus of minus 27. Oh, sorry. It's 16 into 4. So this will be 64. Yeah. So 16 into 4 here. So 64 plus 27 हो जाएगा when you open the bracket. So that will give you 91 K cap. So that is P cross Q. So obviously magnitude of P cross Q is becoming 91. Okay, so hope this is clear to all of you people. Okay. Now when we deal with three-dimensional vectors, there's a further extension of this. Like we have the formula that I cross J is equal to K cap. Like that, if we take J cap cross K cap, it will give us I cap. And we take K cap cross I cap, it will give us J cap. So the logic of these two formulas is the same as the logic of this one. If you just draw the XYZ system and use your right hand palm rule, you'll understand how this works out. Okay. They're all mutually perpendicular. And obviously, this automatically implies that J cross I is minus K. So this automatically implies that K cap cross J cap is minus of I cap, and I cap cross K cap is minus of J cap. So there's a simple way to remember these formulae. There is a circular symmetry, circularity of XYZ. So you can see that whenever I'm doing cross product, going in the direction of the circle, I get a plus sign. So I cap plus J cap is plus K cap. J cross cap cross J cap cross K cap is plus I, and K cross I is plus J. But whenever I go in the direction opposite to the circularity, I get a minus sign. So J cross I gives you minus K. Then I cross K, the last one, gives you minus J. Then similarly, K cross J gives you minus I, like that. Okay, so using this set of formulae, if we have a three-dimensional system, that is the vector E is expressed in three-dimensional form, this actually becomes a 3 by 3 matrix. The first row of the matrix is ijk, the second row is the components of A, and the third row is the components of B. So this is the three-dimensional component form of cross product, okay, as determinant of a 3 by 3 matrix. Okay. So note this down and we'll discuss with an example how this works out. Alright, now let's understand how this sort of matrix is actually solved. So this actually becomes, what we do is you take the first term out from the first row and you're left with these four. So make a 2 by 2 determinant out of it. Okay. Next you take the middle term out, but the middle term you have to remember always comes with a minus sign. This is one extra thing you have to remember. And then you have these four terms because you're leaving out the middle row. So leaving, sorry, the middle column. So you have the first and the third column. So ax, ay, sorry, ax, az, third column, ax, az, bx, bz. And then last step, you take out this term, okay, and as a result of that, you leave out this column. So you're left with these four. But the last term, like the first term, again comes with plus sign. First and last term come with plus sign. First and last come with plus. The middle one comes with minus. Just a minute, my mistake here. This should be the second and the third column, not the first and second, because you've taken out the first, so you're left with second and third. So ay, az, by, bz. And next step, you just solve this as a normal determinant. So it's this minus this. So this becomes ay, bz minus az, by into I cap minus of this now, which is ax, bz minus az, bx j cap, and then plus of this one, which is ax, by minus ay bx k cap. So this becomes the final calculation. So this takes a bit of practice getting used to these steps. Just note it down. I'll explain it to you with an example that will become 100% clear. But once you practiced it, it's quite easy. Alright, so let's look at an example. So suppose the vector A is 2 I cap plus j cap minus k cap, and the vector B is I cap plus 2j cap plus k cap. And we want to calculate A cross B as a vector quantity and then magnitude of A cross B. These two things we want to find out. Okay. So we will just use that standard matrix method. We will express A cross B as a 3 by 3 matrix where the first row will be the unit vectors I, j, k. In the second row will be A's components. So they are, as you can see, 2, 1, minus 1. The second row is B's components, which are 1, 2, and 1, as you can see. Yeah, and next step we will just start solving this. So how we solve? We first take this term out, and along with that comes these four. So plus I cap 1 minus 1 2 1. Okay. The next we take the middle term out, but remember the middle term always comes with a minus sign. So that's one catch you have to remember. And with the middle term we'll have first and third column. Okay. So you'll have these four terms. So 2 minus 1 1 1. Okay. and then in the end we'll take the last term out, k cap. Along with that, we'll take the first and second column because we're taking the third column out. So last term again comes with a positive sign, and first and second columns are 2 1 1 2. Okay, and then we just solve this normally. So this is 1 minus of minus 2, that is this determinant, it goes I cap, then minus of this determinant, so that is 2 minus of minus 1 j cap, as you can see, and then again 4 minus 1 k cap. So our final answer for A cross B becomes this 3 I cap, okay, minus 3 j cap plus 3 k cap. Okay. This is what we are getting as A cross B, and therefore the magnitude of A cross B is just the magnitude of this vector, that is 3. Okay, so once you get used to solving this determinant, it's quite simple really. You have to just remember how to write the rows and columns properly. So remember the first row, the top row is the unit vectors. The middle row will be the components of the first vector here. So it's A. So A's components, AX, AY, AZ come here, the second row. And the third row is the second vector, that is B's components, Bx, By, Bz. And then you have to remember this method of systematically solving the determinant, which I'm sure you have seen again earlier in linear algebra in Kramer's rule and solving of simultaneous equations. So it's that same thing that is used in maths. So make a note of this example, please, people. Okay, people. So hope this is clear. So with this, we finish cross products. Now, students, today we'll be concluding the lecture a little bit earlier right now because I have an important personal appointment. Okay, so we'll be concluding about half an hour early right now. But we have completed the theory part of cross products. So you will be getting a assignment number 7, which has application of cross products, and of course you can complete the module assignments also now, module exercises now. So you have some time off in the vacation coming up, so try to complete that during a bit of free time that you might have, and we will keep one more session for discussion of doubts and questions, but the next chapter we'll be doing after this will be Newton's laws of motion. Okay, so that's it for today, people, and most of all, wish you all a very very happy Diwali. Yeah, Bhargav, that polygon law is part of the component algebra. So whenever you're adding vectors along the sides of a polygon, you just express them in I cap j cap notation and work it out. Okay. Yeah, so thanks for your wishes and wishing you all a very happy Diwali and enjoy your vacation with family and friends. Okay, and we will meet again next week. That's it from my end, people. All the best.